Morning everyone, my name is Benedicto and I'm from grade 9. And I would like to present my experiment where the third Newton's law was influenced to the workings of the wind turbine, which turns the generator to generate electricity. So the main topics throughout the presentation is starting from the definition of the wind turbine for daily life, my main experiment about the wind turbine and things that can go wrong in the experiment and how to solve it. So this is my entire framework, introduction, definition, and so much more. The definition: a wind turbine is a rotating machine that converts the wind kinetic energy into mechanical energy. Before the era of modernization, people used these wind turbines for factories and more. But now, most of wind turbines are used for making electricity via electric generators, which converts mechanical energy into electrical energy, which could be used for industrial applications. There are two types of wind turbine: the horizontal axis and the vertical axis, where the horizontal is more widely used and known, while the vertical axis are quite rare and not that much known by a lot of us. How does this third Newton's law helps our daily life? From the explanation above, the wind turbine moves to the stream flow of the wind. When the turbine is connected to the generator, it can move the generator itself. Inside the generator, there are some coils of copper wire and some magnet poles, which influences the magnetic field to create electricity. And the electricity is usable on our daily life. So this is one example of the diagram. Okay, so let's focus on my experiment specifically. The methods is the essential components for large-scale wind turbines include the rotor or rotor blades and hub, drivetrain, rotor shaft, bearings, brake, gearbox and generator, supporting structure, tower and foundation, electrical components for control and grid connection. Maybe not for this experiment because we simply connect the generator to the LED lights. Now let's go to the preparation. Finding cardboard box from the back of the house at the equipment room. So we have some of those things from the back of our house. I found the solder from my house garage unused for years, and the glue gun I'm using right now is borrowed from my mom's friend. Getting the electric motor / generator from an old RC car I bought years ago, and repairing some of the other stationary tools like scissors, cutters, rulers, etc. List of materials: some cardboard box, an electric DC motor from an RC car as a DC generator this time, some LED bulbs, and at least 1 meter of gauge wires for the circuit. The procedure: the first part that we built is the electric generator housing. We glued 2 small pieces of cardboard to enclose it, and then we made the tower by rolling a long flat sheet of the thinner cardboard layer. And from that rolls of thin cardboard, we made the base of the tower from small box cut of cardboard, and we stack it and glue it to the tower. The wind turbine tower is done. Now we just simply glue it to a bigger cardboard base for the whole thing. The generator was soldered to a gauge wire, which was cut into a length that is not too long nor too short, and it was then connected to 1 or more LED lights. I have 2 in parallel in this case because I like it better that way, via the solder tool. It was a hard time trying to connect the LED to the wires. They just don't like to be soldered and connected, by the way. And then we built the house with cardboards as a decor, with the side panels that have some windows put on from a thin plastic. And don't forget to put in the LED light inside the house along with the excess wire so that the outside will look much simpler and neater. Build the propeller. To do this, we must take 4 coin-scale cardboard circles and we glue it together with a covering also made by a thinner layer of the cardboard. And from there, we made the main shaft of the turbine. To make the blades, we specifically need the cuts for the lower part of the cardboard. The thinner layer is the upper layer, with the size of 8 cm times 2.5, which is just like what I mentioned earlier, specifically 8 times 2.5. It's not urgent, but we cut other curves on the other end, but it's urgent to add the inner curves on the bottom of the blades and glue them to the shaft with one end on the front side of the shaft, just like this. Front side of the shaft and the other side on the back side. So we make it about like sort of incline. 4 blades is used in this case, but you can either use 2 or 3 or 5 or more, but not too much because you might make the turbine too heavy to turn. Do the experiment by blowing it either with the fan or an actual wind and figure out if the light is lit or not. If it does, then the experiment is a success. And then we go to the conclusion. The Newton's law involved in this wind turbine is Newton's third law, where it turns by the action-reaction effect. And besides the Newton's law, it also involves the heat transfer, as the wind itself is from one of three types of heat transfer, named convection. This convection also exists on water boiling, where the hot water rises to the top while the colder water sinks to the bottom to get heated up again. The wind turbine is a pretty good solution for a low budget and low space source of electric power. It's simple, it's compact in area use, and it can be placed basically anywhere that at least have enough amount of wind to blow on. You might also make flocks of them to generate more power in total from the wind if you want. So that's it for the presentation. Thanks for watching.